then here we have at the last page of your Chapter 10 Study Guide tutorial. If you're watching this, I'll go ahead and divulge some information here. These 4 questions are almost exactly like the ones on your test. You have 4 graphs just like this. Some of the equations are in standard form, some are not. And you have to give me all the excess information about the conics, be it the axis of symmetry, directrix line, foci, vertices, etc. So this is a great video to watch of the 3 to make sure you know how to graph each kind. For number 25, we got x squared plus y squared minus 4x minus 8y plus 11 equals 0. We know that the coefficients of x squared and y squared are a and c. In this case, they are equal. So if they are equal, then that implies that this conic section is going to be a circle. So we know what we're getting ourselves into. If this is a circle, we need to put it into standard form so that we can tell all of the other the aspects about a circle, right? The radius and the center point. So we're going to group our x terms, which will be x squared minus 4x plus, leave room for a new c, plus y squared minus 8y, leave room for a new c for those. And then we're going to put our constant on the other side, which will be negative 11. Okay, so in order to find the new c, that's going to be b over 2 squared. So for the x's, that'll be negative 4 over 2 squared. Negative 4 over 2 is going to be negative 2 squared, which is 4. So if I add 4 to that trinomial, I need to add 4 to the right side. For the y trinomial, to complete its square, we're going to take negative 8 over 2 squared, which will be negative 4 squared, which will be 16. So then I'm going to add 16 here, as well as to the right side. Now, we can go ahead and simplify these trinomials. The x's can be rewritten as x minus 2 squared, plus the y's can be y minus 4 squared is equal to negative 11 plus 4 plus 16 is going to be 9. So here's the answer of the standard form. We know the conic it's going to create is a circle. And then when applicable, we know that we have the center of a circle, which is given by HK. In this case, the center is going to be 2, 4. Additionally, we know the radius of a circle is going to be the square root of that constant. So the square root of 9 is going to be 3. So this is the other information. And then we're going to use this information to graph. So the center point will be at 2, 4. From that center point, I've got a radius of 3. So in each direction, 4 main directions, you'll go out 3. Oops, I think I went out too far. And then do your best to connect those points to make a curve. So there's a circle. For number 26, this is not in standard form as it is, so I need to manipulate it to get it that way. Before I do so, though, I'm going to make note that there's only one squared term. So when we only have one squared term, that implies that this is going to make a parabola. So one squared term implies a parabola. Now, the other thing to know, and what I would make sure I put on my note card somewhere, is the orientation. Since I have y squared, that means my parabola is either going to be opening to the left or to the right. Okay, so just so I have some sort of idea of what I'm getting myself into, to the left or to the right. All right, so now I know what I'm trying to manipulate this equation to fit into. Oops, sorry about that. So I want to get my squared terms to the left side, everything else to the right side. So since my squared term is y, everything that has a y I'm going to leave on the left side. Y squared minus 8y. I'm going to leave room for a new c since I'm going to end up needing to complete the square. And I'm going to move the other stuff on the other side. So this will become a negative 3x minus 25. When we complete the square, b over 2 squared will be negative 8 over 2 squared. Negative 8 divided by 2 is negative 4 squared, which is 16. So I'm going to add 16 to that trinomial. What I do to one side, I've got to do to the other. And then when I simplify this next step, so my y trinomials can be rewritten as y minus 4 squared. is equal to, on the right-hand side, I got negative 3x, negative 25 plus 16 is minus 9. Now, we're close. This is not considered standard form. In standard form of a parabola, on the right-hand side, I need to put whatever, whether it's x or y, that needs to be rewritten as a binomial that has a coefficient of 1. So in order for x to have a coefficient of 1, I need to go ahead and factor out negative 3. And in doing so, I'm left with x plus 3. So this is the equation of that parabola in standard form. And then from here, I can start to go ahead and figure out my information. The easiest thing, so let's say when applicable, write the center. We don't have a center point or radius. We do have foci, vertices, asymptotes. We will have an axis of symmetry. No asymptotes. We'll have axis of symmetry and directrix. So the easy part, though, let's start with the vertex. It's going to be HK. Now, please, please, please be careful. Remember, H comes with the X term. So don't make the mistake of just looking at this real fast and going, ooh, the vertex is 4, negative 3. Remember, it's always with the X term versus H. So since it's X plus 3, H will be negative 3, and then K will be positive 4. So the vertex is negative 3, 4. So let's graph that. 3 to the left, 4 up. And then from there, we can go ahead and find the focus. So focus is found by h with the orientation of y squared being our squared term. The focus is found by doing h plus p comma k. Now, I already know h and k because those come from the vertex point. So I've got to figure out what p is. Well, p is not... It does not come straight from the equation, but it comes from the coefficient to the x binomial. So we know that negative 3 is equal to 4p. Whatever's in that spot is equal to 4p. So if 4p equals negative 3, and I divide both sides by 4, then p is equal to negative 3/4. And I'm going to use that to plug in to find the focus point. So if my focus is h plus p, I know h is negative 3, then I'm going to have negative 3 plus negative 3/4, comma, k is 4. Now remember, you're not going to have a graphing calculator to be able to just take care of these fractions very easily. So you need to go ahead and get your common denominators to be able to simplify this. If I want these to have common denominators of 4, I'm going to multiply negative 3 times 4 over 4. Which will be negative 12/4 minus 3/4, comma 4. So when I simplify one more time, I get my focus is going to be negative 15/4, comma 4. So that's the focus. So this point, negative 15/4, comma 4, is going to be almost to 4, negative 4, right? Because that would be negative 16/4. So it's just don't go all the way to 4. And these are going to be pretty close. So just do your best to graph it. It's going to be very close to the vertex, but make sure you label F for the focus. Okay. The only other things we got to graph are the directrix line. Again, with a y squared term for a parabola, the directrix line is found by x is equal to h minus p, which we know h is negative 3. Minus p is negative 3/4, so it's going to be negative 3 plus positive 3/4. So that'll be, again, if I multiply this negative 3, I want it to have a common denominator of 4. So if I multiply that by 4 over 4, then I get negative 12/4 plus 3/4, which will give us the directrix line with the equation x equals negative 9/4. And again, that's going to be a vertical line a little bit beyond negative 2. So you just do your best to be precise in that location. Lastly, before we graph it, we just have one last element, which is the axis of symmetry, which is going to be the shared term between your vertex and your focus. Since the vertex and focus both have y is equal to 4, that is the equation of our axis of symmetry. It's going to go through both of those points, and that's going to be where you can fold your parabola on, and it would be the same. Now, again, I'm not going to be too picky about the shape of your curve. If I was going to be, I'd make you make a table of values. I just care that your focus stays on the inside of your parabola, and that you make sure you go through the vertex point, and that you have all of these other elements graphed. Number 27, y plus 4 squared minus x minus 2 squared over 4 is equal to 1. Equals to 1 means this is either going to be an ellipse or a hyperbola, but since I have a minus sign, that indicates that this is definitely a hyperbola. So I know that this is already in standard form, so I don't need to do that. I don't need to change anything. Already in standard form. I just need to gather my information from here. Okay, so let's do the easy part first. The center of our hyperbola is going to be, remember, you always do your HK. H is going to be with x. So if it's x minus 2, that means the center is going to start at positive 2 for h. K will be negative 4. So let's graph that point first. 2, negative 4. There's our center point of the hyperbola. The next thing I like to find, if you're looking up at the top of the page, we have to find all the things that refer to a hyperbola. Now, I will say this on your test, I also listed the information that you need to give me. So you'll know exactly which details you have to give me and which details you have to graph. You're not going to have to go through the list every time. So next, let's go ahead and take care of the asymptotes, because that's what will be next on your test. The equations, asymptotes, for the asymptotes are going to be y minus k is equal to plus or minus a over b times x minus h. So in order for us to write the equations of the asymptote lines, we need to know what h and k are, which we do. We know the center point. And we need to know what a and b are. Remember, a and b come from the equation. A squared is always the first denominator. So if the first denominator is 1, then that means a squared, let's circle that center point. That means a squared is equal to 1. So if that's the case, then that means a is also equal to 1. The second denominator is always b squared. So if b squared is equal to 4, then that implies that b is equal to 2. So when I write the equation of the asymptotes, I'm going to get y minus k is going to be negative 4, so that's actually going to be y plus 4 is equal to plus or minus a over b is going to be 1/2 times x minus h, which will be x minus 2. And go ahead and leave your asymptotes in this form. You don't need to multiply stuff out and get it into slope-intercept form. What this is doing is at the point 2, negative 4, you're going to graph 2 lines. From this point, you're going to count a positive slope of 1/2 and a negative slope of 1/2. So positive slope of 1/2 will be up 1 over 2, down 1 over 2. And go ahead and connect those points. Again, this is an asymptote, so you'll want to make that asymptote dotted to show that it's really not a part of the curves. Okay, the negative slope of 1/2 will be down 1 to the right 2, and then up 1 to the left 2. And that negative asymptote will be like this. The other things we have to find are the vertices and the foci in order to figure out where the curve should be. So, vertices of a hyperbola. Notice the y squared term is first. So when the y squared term is first, then that indicates that our hyperbola is opening up and down. Okay, so if I use that, if I'm looking at my chart of equations to get a vertex of a hyperbola that's in that orientation with y squared being first, it's given by h comma k plus or minus a. Well, I know h and k already, so it's going to be 2, negative 4. And then I need to go figure out what a is. Oh, I already know it. Sorry, we found it. It's 1. So that'll be -4 plus or minus 1. Literally compute this, okay? So literally tell me, so that means I've got 2 comma -4 plus 1, and I've got 2 comma -4 minus 1. So that means my vertices are going to be at 2 comma -4 plus 1 is -3, and the other vertex will be at 2 -4 minus 1 is -5. So those are the vertices. Let's actually plot those. 2 -3 and then 2 -5. And they should be right in line with the center point, which they are. The last thing to find is the foci, which are given by h comma k plus or minus c. Again, I know h and k, it's going to be 2 -4. And then we got to go find c. Well, in a hyperbola, the relationship between a, b, and c is that c squared is equal to a squared plus b squared. So if I already know a and b, I can square them. A squared will be 1, plus b squared will be 2 squared, which is 4. Then I get that c is equal to plus or minus the square root of 5 when I add that together. And there's nothing I can reduce there. I can't write that in any simplified than it already is. Therefore, you can leave your foci as 2 comma -4 plus or minus the square root of 5. So if you have radicals as a part of your answers, you can leave it written as one coordinate point with the plus or minus. If it's actual integers, actually go ahead and simplify things out. So when you graph the foci, that'll be 2 to the right, and then -4 plus the square root of 5. Square root of 5 is like 2 point something. So -4 plus 2 point something. Just kind of estimate where those fractions are going to be. It's going to be about -1 point something. So it'll be something like this. And then 2 comma -4 minus the square root of 5 will be a little bit over or about 1.5 away from the vertex. And then always label your foci. That way we know the difference between the foci and the vertex. So just label one of them F1, the other one F2. And again, after you graph all of that stuff, as far as the curves go, just to estimate what your curve should be, they should follow the asymptote. Ooh, that's a beautiful curve. They should follow the asymptote, and they should definitely go through your vertex points. All right, last question, number 28. 25x squared plus 9x squared plus 150x plus 18y plus 9 is equal to 0. If I compare A and C, they're not equal. Let's say A and C, they're not equal. The main thing is that they're both positive. Now, I say they're not equal because in a circle, they're both positive as well, except they're equal. So you need to specify A and C are both positive and they're not equal. When that happens, that means we are going to have an ellipse. So now that you know that this should be an ellipse, we need to go ahead and arrange our equation to be in standard form to find all of our information. So we're going to group our x's together. So we've got 25x squared plus 150x plus 9y squared plus 18y is equal to, we'll move that constant on the other side, that's going to be -9. Now, in order for you to complete the equation in standard form, you're going to have to complete the square, and you also need to factor out your current a terms, because your a's need to be 1 before you can complete the square. So for the x's, I'm going to factor out 25. So I'm going to have x squared plus 6x plus, leave room for a new c. Plus, I'm going to factor out 9 for the y, so that'll be y squared plus 2y plus a new c is equal to -9. And then we'll solve for our new c's. So for the x's, b over 2 squared will be 6 over 2 squared, which will be 3 squared, which is 9. Now again, this is where you have to be very careful. When you add 9 here, technically this 25 is being multiplied on the outside. So on the right-hand side, you actually need to add 9 times 25. For the y's, b is 2, so 2 over 2 squared is going to be 1 squared, which is 1. But again, when you add 1 here, this 9 is actually being distributed to it. So on the right-hand side, you're actually adding 1 times 9. When we do that and we actually finish completing the square, Your coefficient is still 25, but the trinomial can now be written as x plus 3 squared plus 9 times y plus 1 squared is equal to, let's see, negative 9 plus 9, this is going to be 0, and then 9 times 25 is just 225. Now, this is the equation of an ellipse. We know that all ellipses have to equal 1. So in order for that to happen, I need to divide everything by 225. And then simplify these fractions. When I do so, 25 over 225 is going to be 1/25. No, that's not right. How about 1/9? That's more like it. So this is going to be x plus 3 squared over 9 plus, now 9 over 225 is 1/25. So that'll be y plus 1 squared over 25 is equal to 1. So this is the first part. This is the equation of your ellipse in standard form. Okay, let's do the easy part. The easy part of an ellipse is the center. It's given by h and k, just like all of the other conics. So h is going to be paired with the x. Again, my x term is first. Now, oh, technically, you know what? I shouldn't write this as my final answer. Hopefully you caught why. In an ellipse, a always has to be bigger than b. So I need to switch these two fractions. So technically my final answer should be y plus 1 squared over 25 plus x plus 3 squared over 9. You have to also switch the x's and the y's. You can't just justify, oh, I need to swap my denominators. No, we're given the equation. We know that these two things have to be equal. All we did was literally swap the fractions. So it's the same thing as saying like a plus b equals the same thing as b plus a. So you literally swap both fractions completely. Okay, so now, still though, when I get my center points, h and k, h comes with x. So instead of x plus 3, h is negative 3. K is paired with the y. Since it's y plus 1, it'll be negative 1. So if you graph your center point at negative 3, negative 1, since my y squared term is first, I know it's being stretched more in the y direction. So that's why I have to write 25 first, because it's bigger. So that means the radius, if you will, the major axis in the y direction, if you take the square root of that, it's going to be 5. So from here, I'm going to count up 5 and down 5 from the center point. That gives me the vertices. So after you graph that, you can tell me the vertices, which one's going to be at negative 3, 4, and the other one's going to be at negative 3, negative 6. And then to get the covertices, under the x squared term is 9, which means the radius in that direction is like 3. So I'm going to count 3 to the right from the center point and 3 to the left, which will give me the covertices. You can label it